Hello and welcome to my video on how to get started with the Microbit, which is a small computer board which does all the clever stuff, and a Minibit robot which allows you to do all the fun stuff. We'll cover getting the app, connecting to your Microbit via Bluetooth, and sending the example code to it. We'll then look at how to directly control your Microbit to make it into a remote control robot. At the end, we'll look at how the example code works and also a few other example codes you can use and a few ideas for things you can do on your own. The first thing you'll need to do is download either the iPhone or Android app from the respective stores. The app pages should look something like these images. If you don't have a phone or tablet, you can still program the Microbit by plugging it in using a USB cable and the Microbit website, though you won't be able to directly control the robot in the same way as through a phone or tablet. Once you open up the app, you should see this screen. In the top left there is a QR code button. This will open up the camera and allow you to scan a QR code, which will take you to some code made by somebody else. The Create Code button allows you to make your own code, starting with just the basics and adding in whatever you like to control your Minibit and your Microbit. My Programs is where you can open all the programs you've made yourself or ones that you've got from other people and saved. Manage Connections is where we set up the connection to the Microbit, and Project Ideas will take you to other people's programs which you can try out. Finally, Monitor and Control is where you can connect via Bluetooth to the Microbit to control it or receive information from it. First, we'll need to set up the Bluetooth connection between the phone or tablet and the Microbit. Press Manage Connection and a screen like this will come up. Press on the white and black Pair a Microbit button near the bottom and follow the instructions. You'll need to make sure the Microbit has power. You can plug it into the Minibit robot and turn on the power switch. Make sure to plug the Microbit in the right way round, as in this picture, with the large white connector in the corner facing the robot. Once you've turned on the power, you'll need to find the little reset button on the Microbit, which is next to the white connector. Press it 3 times quickly, then look at the other side of the Microbit. You will see a 5x5 grid of lights. Some will be lit and others will be turned off. Take notes of which lights are on and which are off, and copy the pattern onto the screen on the app so they're identical. Then keep pressing Next to complete the process. Your phone or tablet will probably pop up something asking if you want to pair with the Microbit. When you've completed this process, you should see a copy of your Microbit's light pattern and a 5-letter name near the top of the screen. It's now ready to download the example code. Press the Home button on the top left to get back to the main menu. Then select the QR code button and the camera will open up. It will probably ask you for permission to do this the first time. Scan the QR code on screen to be taken to the example code. There should also be a web link in the video description below to get to that code. Once you see the example code on your screen, you want to press the Edit Code button on the top right. This might be slightly hidden on the top right edge. This will take you into the coding page on the app. Look for the Save button, which will be somewhere down in the middle at the bottom, and press it. It's important to always press the Save button before leaving the coding page, otherwise your work will be lost. Next, press the Download button, which will be on the bottom left of the screen. This should take you to a screen similar to the screen we used to make the connection initially. Turn on the power to the Microbit, then press the Reset button 3 times to put the Microbit into Bluetooth mode. Press Continue on the app and follow through the pages until the code has downloaded to the robot. You should see the red lights on the Microbit slowly turning on from left to right to indicate the progress of the download. Once this has finished, press the back button to go to the main screen. Now we want to press the Monitor and Control button, and you'll be met with a screen that looks like this. Look down at the bottom and you'll see the Add button on the bottom row, second in from the left. Press this button and then press Gamepad from the list that comes up. The screen should look like this. Next up, look for the 3 dots in the top corner of the black square with the A and B images on. Press the 3 dots and then press Delete. Finally, look for the black and white Start button on the bottom right of the screen. After a few seconds, when you've pressed it, it should connect and it should turn into a square stop button. If it doesn't, you may need to try pressing the reset button 3 times on the Microbit to put it into Bluetooth mode. Once it's connected, give it a few more seconds and then try pressing A, B, C and D buttons on your app and the robot should move. You can now drive your Minibit around. So now we're going to take a look at the example code and give you an idea of how it works to control the robot so that you'll understand how you can change it. So a few helpful little tips to start with. If you make a mistake and you mess something up, you can always use the back button or the forward buttons to undo the mistake. If you grab something and it all just goes wrong, you can make it go back to how it was, so don't despair. You can zoom in and out using these buttons, and importantly there's of course the save button down the bottom. If you ever find that you're trying to use it on a tablet or a phone and things just don't seem to want to be moving about, sometimes the app glitches a little bit, so best just to click the save, go back out and then go back into it through the My Programs button where it will be saved. So let's understand how this code actually works. So all code on the Microbit will, or almost all code, will contain either an on start or a forever block, and additionally some of these kind of blocks down here. So an on start block, whatever you put inside here, you can see the shapes are kind of a bit like Lego. You can plug things together and the shape of the blocks gives you a clue as to where they fit. So this is a diamond shape, would fit in a diamond hole. Circular ones can fit in circles and so forth. You can see they kind of connect together. So an on start block, this will do something once. There you can see it tells you when the program starts. So you want to do things you only want to do once in here. And then there is a forever block. And what this will do is it will loop round and round and round and round. Whatever you put in here, it will do over and over and over again until you tell it to stop. So we don't actually need that one for this, so we'll put it in the bin. So there's on start, things it does once, forever, loops round and round and round. And then there are things that you might call interruptions, which are inputs when something happens or some information comes in to the Microbit that it receives, and it kind of interrupts whatever else is going on to action whatever's in here. So how does this code actually work? Well, first of all, we do this thing which is create a variable. You can find, this is what I call the kind of library, where you find all the different blocks that you can use. And variables are basically where you store a bit of information, store a number of some kind. So in this case, we want to store what we're going to call the last value. So and we're going to set that to 0. So we're kind of basically saying we want no information in there at the start because we're setting it to 0. And then we want to add this. There's this block which says Bluetooth LED service. Now in some of the other example codes, we'll use a different, slightly better block, which is from the Minibit bit in the library, which is called Enable Bluetooth. And I would suggest whenever you're trying to work with your Minibit, you always put one of these blocks in the on start part, because what that means is that instead of having to press the reset button 3 times, once you've uploaded some code with the enable Bluetooth part in it in the on start, as soon as the Microbit turns on, it will turn on Bluetooth, and that will mean that you shouldn't have to do the pressing reset 3 times every time you want to upload new code. So that's a helpful tip. Whenever you're working on your own code, I would suggest always putting an enable Bluetooth block in the on start. But for this example code, we've got Bluetooth LED service, which basically makes it turn on the Bluetooth so that we can connect to it easily using the monitor and control feature. So it starts, it creates a kind of empty place to store some information, and it turns on the Bluetooth. And then this one you can see on event from, and then that's what you need to use. That little thing you can change in the drop down what it is. So if you're making your own code, you'd need to make sure that these bits match what's in the example code. But of course you can start with the example code and then change it. So it's saying whenever it receives information from a controller, it will do whatever's in this code. So whenever we press a button on our phone, the A, B, C or D, it will receive some information, and then it will say, it will use these blocks which are called logic if. So anytime it receives information, it will think, well, are any of these true? Do any of these things apply? And if they do apply, then it will do what's inside. So it will do if the last value, so if whatever's stored in here that does not equal isn't the same as the event value. So we start with 0 here. It sends some information. It puts that information into the kind of event value box, and then it compares them. And if the new information is different from the old information, then it will update this to the new information. So the first bit is just saying, have I got new information? And if the answer is yes, then I'm going to update what's stored in this box so that it knows what instruction it's just received, so it doesn't kind of keep doing the same thing over and over again. Once it's done that, it will say, okay, well, what information have I received? This event value, what button has been pushed on the controller? And you'll notice here there's a little bit of a pattern with the equals. So 1, 3, 5 and 7, and those numbers relate to the different buttons so that you could press on your app, which is A, B, C and D. Don't ask me why it's 1, 3, 5 and 7 rather than 1, 2, 3, 4. It just is. And the pattern goes on in threes for the 1, 2, 3, 4 buttons, which you can find also in the gamepad bit within the iPhone or Android app. So it's let's see where we are. It's made a space for some information. It's turned on the Bluetooth. It's listening. If it hears anything, it updates and says what it's heard. And then it says, well, have I heard number 1 come in, or number 3, or number 5, or number 7? And depending on what it hears coming in, it will then do whatever is in each of these things. So if it hears 1, which is the A button, it will go forwards at a certain speed. If it hears the B button, it will go, that would be the B button, it will go backwards. If it holds the C, it will go left, and the D, it will turn right. And you can see I've made it turn slower than it goes forwards and backwards. And if none of those things are true, so it gets some information, and none of those match, it will stop the robot using its brakes. So sets up a place to store information, turns on Bluetooth, listens for information, stores the information, acts on the information depending on what the information is. So that's the basics of how the remote control will work. And what we could do additionally, if we wanted to, is add in some extra space to use the 1, 2, 3, 4 buttons, the other buttons that you can control. We could make it do different things. So I'll just do a few things just to give you an idea of what it could do. So first of all, we want to make some more spaces. So we can use this handy little button down here. 1, 2, 3, and 4. So I'm doing this on a computer rather than an app because I find it slightly easier, but this should work identically on the app. So I've made some extra spaces, which I'm going to add my new kind of functions in. What does it do when it gets a different bit of information? And these diamond bits, we find it's quite helpful because the color of the blocks usually relates to the colour of the item in the library. So you can see things related to the Minibit are orange. These black event value bits are actually stored all the way down here under control. You can see event value there, and you can see that's where I got the kind of overall bit here from. But at the moment we're worrying about populating these bits. So we will go up to logic because that matches the color, and we will look down here to comparisons, and you can see here's where I got the kind of bigger blocks for this bit. We're going to choose that one, and you just drag it and in it goes, and you can change the symbol. We don't need to on this occasion, and we're going to get an event value and pop it in. So I said earlier they go up in 3s, but they go up in 2s, don't they? So that's going to be 9, and then we will you can try on the app to press and hold, and it may come up with a menu where you can duplicate. It doesn't tend to work quite so well on the app, but I will duplicate for the purpose of doing this a bit more quickly. Oh, that's gone wrong. If you need to get rid of stuff, you can just chuck it in the bin by moving it. There we go. And there, okay. And then I need to 9, 10, 11, 13, 15. And then let's add in some other things for it to do when we press those other buttons. So we could use, you remember on the back of the Microbit there is the 5x5 screen. You can see this is a kind of simulation of the Microbit which can show you some of the things that your Microbit might do when you code it. So we can select show LEDs, and then we can draw ourselves a lovely pattern. So if we press the 1 button on the gamepad, it will put that picture onto the LEDs on the back of the Microbit that it will light up. We could also try something for music. Now, using the music with the Microbit can be a bit tricky when it's plugged into the robot. I think sometimes it just doesn't have enough power to do everything. So I'd avoid using most of these, but you can certainly use this one. Seems to work perfectly well. So we could put it in there, and when that button's pressed, it will play one of these sounds. So we could do that. And what other things can we do? Within the Minibit, you can do things with the lights, although I think, yeah, we'll do that. So, because the Bluetooth and the lights on the actual Minibit robot use some of the same connections, you can't have Bluetooth running at the same time as you do anything with the lights. So if we want to use the lights, we need to first put in one which says disable Bluetooth. Then we can do something with the lights, such as set all the lights to blue. And then we need to put enable again. So it's slightly frustrating, but you just have to remember, turn off Bluetooth, do whatever you want to do with the lights, then turn the Bluetooth back on afterwards. And what else should we put in? I'll just give an example to show how we can use some of the motor controls for the Minibit. They will be under motors. So what we could do is something like this, which whereas these ones will do both the left and right motor forward, both the left and right motor backwards, the left one backwards and the right one forwards, and the right one backwards and the left one forwards to make the robot turn. As you can see here, you could just turn one side for a short period of time, or you can tell it to go forward for, let's put in 1,000, which is 1 second. So here it would turn on the spot to the left. Oh no, so it would turn right because the left motor would move forwards, and then it would just drive forwards for a second, and then it would go back to stopping with the brake. So what you can do is you can keep this the same so that you can drive around, and then you can give the other buttons functions to make the robot do other things. So that's an example of well, hopefully explaining how the basic code works, and an example of how we can add some of the extra button functions and experiment and add different things so that our robot could do more. So perhaps you might like to let's get rid of that one. What you could do is you could make it, when it says show string, that means showing some text on that grid of lights on the back. What you could do is set it up so that you drive it up to someone and then you press a certain button and it will give them a little message that they can read off the back. So of course, if we wanted to download this, we'd want to make sure to save it and perhaps give it a different name so that we know what it is, and then we click download and it would go down to our robot, and then we could come out, go into monitor control and connect, and then we could hopefully get all of these functions working. So to finish off, we're going to have a look at a couple of bits of code which are also available as examples, and you should find the QR code there on the screen, and also a web link down below so you can try and get to these bits of code. So this bit of code is what I would call an autonomous code for the Minibit, because you won't be directly controlling it using monitor and control. Instead, you'll be giving the robot instructions in advance, and it will just follow those instructions forever. So this isn't as complicated as it might at first appear. So let's go through and have a look. First of all, we've got on start, so remember that's what happens at the beginning, and it only happens once. And we've got the enable Bluetooth, and in fact I've been quite overkill here because I've put the Bluetooth service, button service in there. So I've put it all over the place, but really you should just need to put it in the top there, and then that will make programming it easier each time. So we start by turning on Bluetooth. Then we move on to the forever bit, and the forever bit will just go round and round and round. So it'll call it, it will do this, then this, then this, then this, then this, and go back to the start. So the main thing in this code is what are called functions, which you can access from this button here, which is usually hidden under the advanced. And what a function is a kind of efficiency thing. So it enables us to write out or make our blocks just once, and then each time you want it to do this, it will we just put in to call that function to do this each time. So each time this block comes up, it will do both of the things in here. And you can see that's really quite useful for something like this one, where there's all these instructions in here, and yet it keeps it neat and tidy, because in our main one we just say call square and it will then go and do all of those. So as you can see, the aim, hopefully with the name drawing, the aim of this code is to do drawing. There's a little pen hole in the middle of the Minibit, and you can put a felt tip pen in. If it doesn't quite fit, you can wrap masking tape around to get a nice snug fit. You want the pen just to be touching the floor under the robot, and you can get some nice big sheets of paper and let your robot loose, and it will draw all over the floor. So the idea is that this code, which makes the robot run at a certain speed for a certain length of time, a quarter of a second, and then stop, it should go forward about 8 centimeters, but your robot may be different. And this, of course, you can see is the same, turning left and turning right. And then this one is to try and draw a square. So it goes forwards, it turns right, it goes forwards, it turns right, forwards, turn. So hopefully it'll roughly draw a square using this. And this one is a bit different in that the attempt is to draw a circle. So we are using, you can see this nice green block here called loops, and loops fairly obviously will keep doing the same thing. In this case it will do the same thing 64 times, or until certain conditions are met or with a certain frequency, but we don't need to worry about those too much because we're just thinking about that. So what it will do 64, every time this is called, it says call circle, it will think, I'll do this, and then it will come down to here and it will think, right, I have to do this 64 times. So it will go forward, stop, turn right, stop, then it will do it again and again and again until it's done it 64 times, and hopefully that will draw a whole circle for you. So there's two different ways that you could use this example code. One is that you could dump all of these out, and you could just choose which ones you want to put in, and you could kind of make up your pattern that the robot will draw by just putting these in. So that's one thing you could do. A second thing you could do is you could fiddle with these numbers. So you could turn up the speed, you could turn up the time, so milliseconds, 1,000 milliseconds in a second. So that's 1 second, quarter of a second. So you could mess about with these numbers, make them up and down. Bearing in mind, when you get down to very low numbers for the speed, you may not even notice the robot moving. So I wouldn't go down very low with those numbers. And it doesn't seem to make a huge amount of difference what you set them at. But obviously the time will make a difference. You know, the number of times it repeats, that kind of thing. So one way you could mess about with it to change it is just putting your own kind of list in. A second way is to change some of the numbers in here. And a third way could be to make your own functions. So to do that, you'd go on functions, make a function, you type in here, let's say that, and we're going to say that's done. And then we would, where are we going? Here it is. So it's appeared, and it's got its name. And why don't we, just for the sake of it, make a happy face. So wonky happy face, there you go. Give him some hair. Looks like a Pokeball now. So when it is, when that function is called, it will do this little picture and then it will say hello. So we will add in hello. So what would happen now is it would say, it would switch on, turn on the Bluetooth, turn on the Bluetooth again because I've done some overkill. Then it would call this one where it would go forward. Then it would call this one where it would turn left. Then it would go backwards, and then it would show these and it would say hello at the end. So you could use these if you wanted to kind of program in it to do a kind of dance routine on its own, or as I say, to make it do drawing, and it will remember when you put this code in, it will just start going on its own, so don't leave it on a table or anything like that because it might well drive off and break. So that is an example code that you can use to do some drawing with your Minibit. So for this last example, we're going to look at adding some bits to the basic controls, which will enable our Minibit and Microbit to respond to the things that are going on around it. So we'll need to add a forever to start with in, which we can grab there. So the first thing we'll add is for the, it's got a built-in microphone on the Minibit. So we'll add in something to see if it gets too loud, we'll make it do something. So we're going to want one of these if, as there conditions, if something is happening, then we do this. And we'll put this comparison. And then we will have a look at inputs. And we will find sound level down the bottom, and we want to say if the sound level is greater than a certain number, then we do it. So if it's these kind of numbers generally with the inputs can be between, as you can see here, 0 or 255. So 255 would be very loud and 45 would be very low. So let's go for 230 as quite a loud one. So let's say you're driving around your robot and it gets into a loud place. Then what we could do is we could make it say something. We could type this in, we could say too loud, and it would say that when it was too loud. And perhaps we'd also want to do something with the LEDs. So remembering we're turning off the Bluetooth, we are going to set the LEDs to be a rainbow, and then we are going to turn on the Bluetooth again. So it will, if it's too loud, it will go, oh, it's too loud. It will say, it will hear the sound level, monitor the sound level. It will say too loud, turn off the Bluetooth, set the rainbow LEDs to a rainbow color, and then it will turn on Bluetooth again. What we can also do is another thing very similar to do with the sound, the light level. So it can actually detect light levels using the LEDs on the back. So light level, we bring that in, and we will put 150, just as an example. So perhaps if you were in somewhere that was dark and you drove into somewhere brighter, then it would say, oh, the light's got more, so I'm going to do something else. So in this case, why don't we make it play a little sound, because it's going to be happy that it's gone in the light. And what we could do as well is get some LEDs, and if we tell, we could just change the color of one of the LEDs on this occasion. So they can be between 0 and 3, these LEDs. They should be marked on the front what number they are, and we'll change that to green. And then of course we need to enable Bluetooth again. So disable, set the LEDs to rainbow, enable. When the sound is too high, depending on the light level, we will do certain things as well. So it can respond to the sound level, the light level, and finally we will get it to respond to if it gets knocked, perhaps if you crash into it, or maybe if you have some other remote control toys, you could drive your robot around to escape and someone else could try and catch up with it and knock into it. So this is a bit like this one. This input is a kind of interrupting one. So when it happens, it will interrupt whatever else is going on and do the different things. So we want to choose these different levels of force. That's very light and obviously slightly more impact force. So we'll put 6 grams of force. So when it detects a certain amount of force, why don't we make it say out and make it show a sad face. Sad face. So you can be driving around your robot and it can respond to sound, to light, or to impacts. And those are kind of examples of some of the things you can do. So I hope this has been helpful for getting started with your Microbit and your Minibit, and has given you a few ideas of what you can do to program it. And the best thing to do is just to try and experiment. There's lots of tutorials on YouTube and other places you can find, and if something doesn't work, try it again, or look up online and do a bit of research to learn. But there's plenty of things you can do, so hopefully you will have some fun with your Microbit and your Minibit.